Welcome to my video on 11-10 normal distributions. So today the aim is to use a normal distribution. We're going to define it, explain it, and try to apply it to different types of questions. So to start us off, I have 3 thinking questions. Think about the heights of the students in your class. How do you think those heights will be distributed? Well, let's think about in a general classroom, right? You may have some tall people. You may have some short people, but the majority of people are going to be of average height. So if we were to draw this as a distribution, right, going from short to average to tall, right, we would have less short people and we would start increasing as we get towards our average and then follow suit on the other side towards the tall. So kind of all of our information is gathered around what would be the average height. Now, let's think about the second question. How would the heights of a professional basketball team differ from the heights of your classmates? Well, what do we know about professional basketball players? They're tall. So if we're on the same scale of short, average, and tall, right, we would have very few short people, and as we get towards the average we would start increasing until we get a spike in the tall section, right? Now think about the third question. How would the heights of the U.S. Olympic women's gymnastics team differ from that? Well, the women's gymnastics teams are going to be really short, right? Gymnasts tend to be very short, so it's going to be the opposite of this distribution. So again, if we're going from short to average to tall, we would see a spike in the short, and as we get from average to tall, we would get less and less people. So these two distributions here, right, favor one side. They have a bias towards one direction, tall or short. We would call this skewed. So we're not going to be focusing on these skewed distributions for today. We're going to be focusing on the ones that resemble the average height. And we have a special name for that. So a data set is said to be normally distributed if the data values tend to be around a central value. They tend to group around a central value. So if we take a look at this particular graph, right, we have a central value here, and all the other values kind of bunch up around it and get smaller and smaller as we go towards the outside. So we often call this a bell curve because the shape of our distribution, the shape of all of our data values resembles the shape of a bell. Now, what's interesting about this? Well, when we are normally distributed, there's a sense of symmetry, right? If I folded this down the center, the opposite sides would be approximately on top of each other, right? They would overlap. So normally distributed information has a symmetry around this center. So now we're going to be marking this center off with our mean value. That's how we're going to be measuring things. The center value we're using is the mean, and we're going to see how that compares for different examples. So now the normal distribution is a given distribution. So basically, if we say something is normally distributed, we are saying that it follows along this given pattern. So in the old days, we would have to memorize these percentages because these are the percentages assigned to the normal distribution. Okay? So again, we only are going to use these percentages if the directions tell you that something is normally distributed or follows a normal distribution. So remember how I said symmetry was important for this normal distribution? Well, think about this. If we were to break this bell shape in half, right, and think about the percentage of information that should be above it and should be below it, well, if we split percentages in half, that means 50% of the information is above it and 50% of the information should be below it. And if we look at the values assigned to this chart, basically what happens is they split up this 50% into different sections. If I added all of these values together, I get the total 50%. So now how are they split up? Well, that you see these 1, 2, and 3, these are all related to standard deviations. Remember, standard deviation is a measure of how spread out our information is. Okay, so if we find our standard deviation, we can see how our numbers are distributed. Standard deviation. Okay, so if we look at one standard deviation away from our mean, right? Remember, yesterday I talked about one standard deviation away from my mean is everything above and below one standard deviation. So if we take a look at the percentages on this table, 34% of the information that I have should fall between the mean and one standard deviation above it. On the flip side, 34% of my data, another 34% of my data, is between the mean and one standard deviation below it. So together, as a whole, if we are measuring one standard deviation away from my mean, there should be approximately, right, because that's what the squiggly means, approximate, 68, because we get 34 plus 34% of the data falls within this one standard deviation of the mean. Okay, so now let's take a look at two standard deviations. Okay, two standard deviations is when we take that standard deviation and add it twice to go above and subtract it twice to go below. So these would be all the values in between would stand for the two standard deviations away from the mean. So how do we find out the total percentages of data that falls within two standard deviations? Well, we have to add 13.5 plus 34 plus 34 plus 13.5, giving me a total of 95. So we should expect 95% of our data falling between these the two standard deviations. Now, if we bump it out again to 3 standard deviations, right? That's all the way here. There's not much left, but if we bump out to 3 standard deviations, what are we going to do? Well, we're going to add this 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, and we get a total of 99% of our data should fall within 3 standard deviations of our mean if it is normally distributed. Okay. Now, if you look up the normal distribution on your own, you might see some other measurements. You might see 34.1 in the middle, and that's because these percentages are estimates. They're approximate, right? If something is normally distributed, it follows this pattern. It may not be exact. So the way that we split up our percentages might be slightly different from another source, but we're going to be sticking with these percentages as our estimates. Okay, so let's see how we can apply this. So we're looking at page 742, number 3. The scores on an Algebra 2 final are approximately normally distributed, right? So again, everything we do is approximate. So what does that mean? That means if we're looking at a test, right, most of the values are going to be around an average score. Some people will be on the lower end, some people will be on the upper end, but for the majority of students, we're going to be in this middle section. So the mean score for this particular final is 150 with a standard deviation of 15. So if we were going to label the normal distribution curve with the information for this particular problem, we would label the center as 150 because that is my mean. And we continue to label each standard deviation away from my mean by adding or subtracting. So one standard deviation above would be 150 plus 15, which is 165. Plus another 15, 180, plus another 15, 195, right? So those are the scores above the mean. Now we subtract. 150 minus 15 is 135. Minus another would be 120. minus another 15 is 105. Okay, so we've labeled 3 standard deviations away from our mean. And thinking about the percentages, this means 99.7% of my students should score between 105 and 195 if it's truly normally distributed. Okay, so now let's answer the question. What percent of students who took the test scored above 180? So if we're looking at this chart, where are we looking? Well, 180 is 2 standard deviations above my mean. I want to know what percent of students scored above this score. Well, think about it this way. Everybody below this is scored below 180. And this area right here, this bottom half, that's going to represent everybody who scored above 180. So how do we find the percent? Well, we add up the individual percentages of all the different sections. So I would add 2.35 plus 0.15 to get a total of 2.5%. So 2.5% of my students who took this test scored above 180. Okay. That means if we think about how many students scored below that, right, we would take 100 and subtract that. That means 97, I'll put this on the side, scored below the percent, 180 as a score. Okay. So now, if 250 students took the final exam, approximately how many students scored above a 135? So let's erase this because we're using a new point of reference. So 135 is here. We want to find how many students scored above this. Well, if we think about the percentage of the students who scored above this, we need to add all of these percentages that fall above the 135. So 34 plus 34 plus 1, 3.5 plus 0.15 to get a total of 84% of my students scored above 135. But it doesn't ask me for 84% of my students. It asks me how many students scored this. So if we take the total number of students and multiply it by the percent as a decimal, we get that we have 210 students, or 210 out of 250, that scored above a 135. Okay. So now, we don't need to memorize these percentages. In the olden days, we did. Now we have a calculator that has the buttons that we can press. So if we want to find the percents related to a particular value on the calculator, what we're going to press is second vars. And when you press that, this menu will come up. So now, to be able to find the percents on the calculator, we are going to choose option number 2, normal CDF. When you press that, right, you press enter. This screen here is what's going to pop up. They're going to ask you for a lower bound, an upper bound. This mu symbol, I know we haven't used it before, but it's going to represent the mean for these ones. And the sigma is still our standard deviation. So you're going to fill in the information specific to the problem so that it can give you the generated percents. So this asks, what percent of students score between 120 and 160, given a mean of 150 and a standard deviation of 15? Well, my lower bound is 120, upper bound 160, my mean is 150, my standard deviation is 15. When I press that, this will pop up on my screen. Now, this is what you're going to write to show work. Okay, so you're going to write that sentence. And then it gives us this percentage, this decimal. In order to be able to answer this question, the only thing we have left to do is to convert this into a percent. So what percent of students scored between 120 and 160? About 72.5%.